Okay, let's finish up probability here in section 2 of chapter 10. So this will be video part 2. We have complementary events. Those are events that add up to 1. So as I was talking about in the previous video, if you have something that is 60% probability, then its complement would be 40%, or the idea of that not happening would be 40%. So it's just the opposite, its counterpart. Kind of like angles, how they would add up, complementary angles add up to 90 degrees, same kind of thing. And this adds up to 1. So using Bucky's deck of cards from example 10.3, what is the probability for Satchel not to draw a queen? So we want not queen. So we can use probability of queen with a bar over it, means not. And then we would take 1 minus probability of the queen, which I believe we already figured out, but we'll just rewrite it here. 1 minus 4 over 52, or we could just use our reduced version. Okay, so we would get 12/13 is our answer as a fraction. It would be about 0.923, or you could write it as 92.3%. That's pretty common language to write it out with symbols, probability of not queen, or you could answer just in words. So here we're going to now look at probability of 2 independent events, like what is independent and what is not independent. Because before we were finding intersections if we we will find some intersections of probabilities by multiplying, but only if they're independent. So if they're not independent, we can't do that. So we do need to differentiate. So if one doesn't affect the likelihood of the other occurring, then they are independent. When Satchel draws a card, he puts it back in the deck before drawing another card. So that would be independent, because on the next draw there's still the same amount of cards, everything's still as it was. But what if Satchel draws a card that's a spade and he doesn't put it back in the card, into the deck? So that means there's 1 less card. There's only 51 cards total, and there's 1 less spade. So our counts all need to change. So you'll see that as you read through the book and you do your homework and such. So if Satchel had replaced the spade before drawing a heart, how would this probability be different when he did not replace the spade? So let's look at if he did replace. On the next draw, if you're still trying to figure out that same probability of drawing a spade, you would still have the 13 out of 52, or a quarter of the deck would be spade, or 25%. But if you didn't replace it, on that next time you would only have 12 spades out of 51 cards, and so that would be a different situation. We could just see it as a fraction, or note that that's 0.235 instead of the 0.25. So the probability goes down a bit because there's 1 less spade. So this example is also in your book, so take a minute to think about it, maybe pause the video. But suppose it will rain tomorrow in Houston, Texas, and also rain in Galveston, Texas, a city near Houston. Are these 2 independent events? So the near is the key word there, and I would say they are not independent because they're so close in proximity that one could affect the other. here we have the probability of two independent events. So if they are independent and one doesn't affect the other, we can just simply multiply the probabilities together. But if they're not, there are other ways to deal with it that you'll see. We're not going to get too involved in probability, just want to do a little bit with it. So there'll be a lot of, you might want to check out the extra help videos, the course overview videos, and the example videos, as well as the help tools that are in your electronic homework. So there's plenty of support, but it can be a little bit vague, so feel free to ask me questions in either the discussion forum, help each other out. I can chime in there too, and also you can hit ask instructor a question right in the software and get a reply. So what is the probability of Satchel drawing a heart, replacing the card, and then drawing a spade? Okay, so this is an intersection. We consider it that because these are happening together in the same situation or case. So we have probability of a heart intersect with a spade would be probability of the heart, which is, as we could figure out before, but 13 over 52 times 13 over 52 is the same for the spade. And those would reduce down to be 1/4 each. You could just write that from the get-go. And that would be 1/16 probability. If you wanted to do it as a decimal, we would get exactly 0.0625. We like to have our 3 significant digits there. You could convert 2%, 6.25%. Sometimes I just write an or there, saying like it's one or the other. That is fine. So now example 10.9, pause the video and try that one for classwork right now. So just take a look at that. We have in a drawer there are 10 pairs of socks, 6 are white, and 7, there's 7 t-shirts, 3 of which are white. What is the probability of selecting a white pair of socks and a white t-shirt? So if we could think one, in this case, doesn't affect the other. Later on, we might see where some things do. So go ahead and use that formula that we just talked about. Pause the video and then check back for the answer. Okay, so here's your answer. Would be 9/35 probability that they are both white. You could have written it as 0.257 or 25.7% chance of getting both white, a white sock and a white t-shirt. Any form of these is okay unless it's specified on directions of a quiz or something or a project that it should be just as a reduced fraction or just decimal or just percent.